Let us read the question here first. Okay, suppose in an electrodynamic ammeter, the mutual inductance between the two coils, fixed and moving coils, varies as this function m equal to 600 sine theta minus pi by 9 microhenry. So this multiplied by 10 to the power minus 6 in Henry, where this angle theta is in radian. Okay. Then in the question above, the spring constant is given as 0.1 micro Newton meter per degree. Okay. Now in the part A, first part, we have to estimate the deflecting torque. Okay. Deflecting torque. But we know that in steady state, deflecting torque should be equal to the controlling torque, and the controlling torque is given by the spring constant, that is 0.1 micro Newton meter per degree multiplied by the angle of deflection, which is given as 40 degree. Okay, so this comes out to be 4 micro Newton meter. So this is the answer for part A. Okay, now in part B, we have to estimate the current that flows through the two coils. Okay, and for that we will use this relationship that deflecting torque is equal to current square I square into dm d theta, where m is the mutual inductance and theta is the angle of deflection in radian. Okay, please note that this angle should be in radian for this relation to be valid. And m mutual inductance should be in Henry, current is in ampere, then this torque will be in Newton meter, everything in SI units. Okay, so now the expression of m is given in the question here. Okay, so if you differentiate this expression, you will get dm d theta equal to 600 cosine theta minus pi by 9 into 10 to the power minus 6. Okay, this is in Henry per radian. Okay, and I square I will keep as it is. Now the deflecting torque TD, this we have already found it to be 4 micronewton meter. So 4 into 10 to the power minus 6 Newton meter, that is in SI unit. This is equal to I square into 600 cosine theta. Now theta is given to be 40 degree in the question. So 40 degree means 4 pi by 18 radian minus pi by 9. Okay, into 10 to the power minus 6. In this equation, everything is in SI units. Yes, I'm not writing the units explicitly. Okay. 10 to the power 6 cancels from 10 to the power minus 6 cancels from both the sides, and we are left with from here we can write I square should be equal to 4 divided by 600, and cosine this will be 2 pi by 18 radian, that means 20 degree. So cosine 20 degree. Okay, and this will be in SI unit, that means ampere square. Okay, left hand side is current, And from here, if you put the value of cosine 20 degree, and then if you take the square root of this right hand side, you will get I equal to approximately 84 milliampere. Okay, that's the answer.